Section number 1
of Worlds Within Worlds, The Story of Nuclear Energy by Isaac Asimov. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Blaine Aidan McCoy, Riverside, California. Introduction. In a way, nuclear energy has been serving man as long as he has existed. It has served all of life. It has flooded the earth for billions of years. The sun, you see, is a vast nuclear engine, and the warmth and light that the sun radiates is the product of nuclear energy. In order for man to learn to produce and control nuclear energy himself, however, something that did not take place until this century, 3 lines of investigation, atoms, electricity, and energy, had to develop and meet. We will begin with atoms. Atomic weights. As long ago as ancient Greek times, there were men who suspected that all matter consisted of tiny particles which were far too small to see. Under ordinary circumstances, they could not be divided into anything smaller, and they were called atoms, from a Greek word meaning indivisible. It was not until 1808, however, that this atomic theory was really put on a firm foundation. In that year, the English chemist John Dalton, 1766 to 1844, published a book in which he discussed atoms in detail. Every element, he suggested, was made up of its own type of atoms. The atoms of one element were different from the atoms of every other element. The chief difference between the various atoms lay in their mass or weight. Dalton was the first to try to determine what these masses might be. He could not work out the actual masses in ounces or grams, for atoms were far too tiny to weigh with any of his instruments. He could, however, determine their relative weights, that is, how much more massive one kind of atom might be than another. For instance, he found that a quantity of hydrogen gas invariably combined with 8 times its own mass of oxygen gas to form water. He guessed that water consisted of combinations of 1 atom of hydrogen and 1 atom of oxygen. A combination of atoms is called a molecule, from a Greek word meaning a small mass, and so hydrogen and oxygen atoms can be said to combine to form a water molecule. To account for the difference in the masses of the combining gases, Dalton decided that the oxygen atom was 8 times as massive as the hydrogen atom. If he set the mass of the hydrogen atom at 1, just for convenience, then the mass of the oxygen atom ought to be set at 8. These comparative or relative numbers were said to be atomic weights, so that what Dalton was suggesting was that the atomic weight of hydrogen was 1 and the atomic weight of oxygen was 8. By noting the quantity of other elements that combined with a fixed mass of oxygen or of hydrogen, Dalton could work out the atomic weights of these elements as well. Dalton's idea was right, but his details were wrong in some cases. For instance, on closer examination, it turned out that the water molecule was composed of 1 oxygen atom and 2 hydrogen atoms. For this reason, the water molecule may be written H2O, where the H is the chemical symbol for a hydrogen atom and O for an oxygen atom. It is still a fact that a quantity of hydrogen combines with 8 times its mass of oxygen, so the single oxygen atom must be 8 times as massive as 2 hydrogen atoms taken together.